Okay, number one. Ready, Bobby? Number one. Here we go. Okay. So, what I'm going to do, just kind of like the first multiple choice question on today's group, is make sure I look through all the choices or all the descriptors before I come up with the right answer. Each process of elimination. So on this one, he increases his speed for 30 seconds. Does this show that? No. Yeah. Is this one? No. He only does it for like 22 and a half because he should use 7 and a half. Does this one show that? Well, he does for 30, but he actually does for like 37.5. So really, we're pretty sure that's right, but let's make sure. He stays approximately the same. So he goes for 30 seconds. He increases his speed. And it is at a constant rate, right? He stays approximately the same for 20 seconds. Yeah. He slows down to a stop. Yeah, this means he stopped, right? So definitely A. Number 2. Okay, the graph displays the number of boat rentals at a rental shop. The shop is open from March to October. So there's nothing wrong with writing that on here. Okay? Might help you. Describe the change in the number of boats rented over time. Of course, we don't have numbers here, right? It's a qualitative graph, not a quantitative graph. But we have an idea. We know that more boat rentals took place in March than October. Okay? Write a statement. Describe the change in number of boats rented over time. Okay? So starting in March, what happened? Okay? People started renting how? Okay? Started renting boats, increasing, that's kind of important, increasing at a constant rate. Once summer hit, I would say, it stayed at a steady rate, or they continued to rent at a steady rate. I'm going to put that, I like that better. They continued to rent boats at a steady rate. The steady is going to be like this, right? They continued to rent boats at a steady rate. Near the end of the season, or probably around the end of August, when people go back to school, right? Rentals began to decrease at a constant rate. And I will give you more space on the test on Monday. Began to decrease at a constant rate. Okay, that's pretty good right there. That's real descriptive, using nice terms like steady rate, constant rate, increasing, decreasing. Those are the kind of words. Those are comparative words. Well, increase and decrease. So this is how many boat rentals. So let's double check. The graph displays the number of boat rentals at a rental shop. So here there might have like 50 boat rentals, and then up here they're at 100, and then here they're doing 100 a day. Because this is how many boat rentals. Okay, good thought. Versus they aren't renting any boats, but they are renting boats here. It's just that every day they're kind of renting the same number of boats. That would be like a house. Okay? All right, comparison. Now, for some reason, my 5th grade class was up in arms about this. This seemed pretty obvious to me. Remember, comparison is, so the comparison here, whoever's clicking their phone, please stop. Okay? It just says, compare, just write a statement comparing the number of rentals at the beginning of the season and the end of the season. They rented more boats at the beginning than the end. Okay, and remember we want to use comparative words like more, less, because we don't have specific data. Like in the last page, we actually use numbers, right? 7 more, 7 less, and the end uses. So that would be a good answer. Anybody else have one they think would be right for that one? Anyone? Anybody have anything else that they put here that they think would be right? Because there is some subjectivity here. Obviously, you're not going to love the exact same thing, but you need to have something like that. Okay? All right, moving on to page 2. So this graph displays Carla's height. Does Carla's height increase at a constant rate? Okay, we're going to use the highlighter. Is it increasing at a constant rate? We're talking height here, over time. Okay? Does your height then increase more quickly? Is that more quickly? Yeah. And then her height increases slowly. Is that slowly? Compared to that, it is. And then does her height stay the same? Okay, we nailed it on A. I double checked to make sure that A is right. Okay. How about the next one? Just to hit a golf ball, the graph displays the height of the golf ball. Describe the change over time. So the height of the ball decreases at a varied rate. Is it decreasing to start? No. Okay. The height of the golf ball increases at a varied rate. What does varied mean? Very good. There's a pattern, kind of like our parabola is, right? It's a pattern. It looks like this is a parabola, actually. It's a pattern, but it's varied. It's not constant like Carson said. Until it reaches a maximum. Where's my maximum? In the middle. Right. The top, right? The peak. Good. Okay. And then we have then the height of the golf ball decreases at a varied rate. Is that it? So it's definitely B. Okay, moving on. Obviously, those are going to be right or wrong. Okay, the next one. This is right off of a Smarter Balance kind of assessment. You'll have one similar to this on the test. On Monday, I just changed the table. I didn't change the graph. Is the water temperature increasing between hour 1 and 2? Is the water temperature increasing between 1 and 2? Yeah. Yes. Okay. Is the water temperature increasing between hour 3 and 4? Definitely not. Okay. Is the water temperature constant between hours 0 and 1? The water temperature is constant. What does constant mean? The same. No, it's not. It's increasing. Okay, so that's false. Okay? There's a pot of water in the stove. The water's at room temperature. Okay? So where do you think the room temperature would be on this? What do you think this would be? Cold, right? What's this going to be? We're talking about what kind of water? Boiling. Now, you don't need to do this, but it just gives you an idea, right? Boiling versus cold. And I don't know, cold is to be freezing. Okay? And it doesn't have to be exact, but it's going to have to be somewhere in here. The water's at room temperature, and it increases at a constant rate until it boils. Okay? So your water is going to keep increasing at a constant rate, which should be straight, until it boils. Then what's going to happen? How long does it boil? It doesn't say, does it? Boiling? Well, what is boiling? Because once it starts boiling, it's going to stay at that temperature. Now, because every substance has a different boiling point. The water, oil, like aluminum and steel, like a Kaiser, that is very high boiling point. Anyways, so it's boiling, and then it remains at a boiling point. The stove is turned off, so the temperature of the water decreases at a constant rate until it reaches room temperature. Something like that, right? Because it starts where it finishes at room temperature. Room temperature, room temperature. So something, you don't have to label it, but this is what yours should look like. Now, it doesn't have to look exactly like that, but it should have to increase at a constant rate, decrease at a constant rate, and it should level out in a minute. Any questions on that one? Okay, 7. Interpret this equation y equals mx plus b, because we also are comparing linear and nonlinear relationships. Is this linear? No. Be careful. Plus 10, plus 10, plus 8, plus 8. Done. Okay? This one's going up at a constant rate, right? But both variables have to go up at a constant rate. Therefore, the slope is not 10, it's not 8, okay? It's not linear. So no, you could just say because cost does not increase at a constant rate. Would be a really good answer. Okay? Because we know it has to. Yes, Kellen? Oh, you know what rock means. What does rock mean? Oh, good. Okay. Number 8. Now we're just graphing our parabolas, right? Well, on these two, right? I would always use -2, -1, 0, 1, 2, unless otherwise appropriate. And I think the way I designed the test, it works for all of them nicely. So if I put in -2, don't forget to hug it with parentheses. Okay? So -2 squared is 4 times 3 is 12 minus 2 is 10. So a lot of times, a lot of you are figuring out it's just easier to write them all down and then do the math. Because then you can quickly do the order of operations and go -1 squared 1 times 3 is 3 minus 2 is 1, -2, and then we know because it's parabola we're going to get that symmetry, and then I can graph those ordered pairs. And if it doesn't fit on the graph, you know about where it is. Okay, -1, 1. 0, -2 is called the what? No. No. Well, it is the y-intercept, but it's also the what? The minimum, but it's also the what? It's the minimum point. Vertex. Good. Vertex. Okay? Now you do need to make it look somewhat like this. It is curved, so you can't use a ruler, but it should look pretty much like that. I will look to make sure your points are in the right spot. So if they're not, you're going to lose points. Okay, the next one, same dealio. I'll go with parentheses, right? So then we're going to go ahead and -2 squared is 4 times -2.5 is -10 plus 3 is -7. What do you get here? 0.5. Here? 0.5. I knew that. Okay? So then I'm going to go ahead and go -2, -7, -1.5, which is about halfway there. We have 0, 3. And then I know this is going to be symmetrical. So 1, 2, 1, 2. And it's going to look like this. I missed it. Whoops. I was in the shadows. That's my excuse. I don't like it. I'm going to fix it. That's why we use pencil and math, right? Mm-hmm. Better. Okay. Piece cake, right? Alright. Make sure you, like I said, hugging it with parentheses is the most important on those. Okay, next one. Notice now that they are cubic functions because we're cubing x. So we have 2, -2 cubed, 2, -1 cubed, 2, 0 cubed, 1 cubed, -2 cubed. So we're going to get -8 times 2, -1 times 2, 0, 2, 16. They're not always going to be symmetrical like that on a cubic function, but when you're not adding or subtracting something, they will. So I'm going to get -2, -16, which is way down here somewhere. Okay, we're going to get -1, -2. We're going to get 0, 0, 1, 2, and this one's going to be way up here-ish, right? And these are always going to have this kind of shape.
Does it matter if you actually go that high?
I'd like you to go close, but on the unit test, I made it so maybe if it goes above, it's only going to be barely above it. Barely below it. Okay, the last one on cubic functions. Okay, -2, -1, 0, 1, 2. What were our outputs on this one, guys? Maybe I better do this one. Don't forget about the naked negative, right? Naked negative. Put some clothes on it. So we have -1 times -2 cubed minus 1. -1 times -1 cubed minus 1. -1 times 0 cubed minus 1. -1 times 1 cubed minus 1. So -8, +8, -1, 7. Some of you might have made a mistake here, so double check. -1, +1, 0. 0, 0, -1. 1, -1, -2. 8, -8, -9. So -2, 7. -1, 0. 0, -1. And I know that always happens in the middle on your cubic functions if you haven't figured that out yet. And then 2, -9 is about right there. So Carson, I'm kind of answering your question about just kind of estimate where that -9 would be. And there it is. So it goes the opposite direction because it's negative. Okay. Next page. This one is definitely linear because it's in the format y = mx plus b. This one's definitely not because it's not a line, not straight. This one you're going up by 4 each time because you're going up by 1 here, so that is linear. This one is not because x is going down by 1, yes, but x stays the same, then it goes down 4, then it stays the same. So that would not be linear. You're welcome to use graph paper if you're not sure. And then the bonus, Tanya drove away from her house. So what are my two variables here? What are my two variables? Nope, stop speed. Time and what? Nope. Distance from house. Distance from house. Good. Okay. So when she starts out, how far is she from her house? She's at her house, right? She's right here. Okay. So what does she do? She drives away from her house and comes to a stoplight. Okay. So she drives away from her house. She's going at a constant rate. She might stay at the speed limit, and then she comes to a stop, right? And you don't slam on the brakes and go straight down. You come to a gradual stop. Okay. Choose the stoplight until it turns green. What are we going to do when she's at the light? Waiting for it to turn green. Say again? Oh, good point. You're right. Okay? If it was speed, it would go down. Jacob caught my mistake. Since it's distance from house, it won't go down. Very good. Okay? So I'm going to go like this. Okay? And then I'm going to stop here. And it says, after the light turned green, so she's just stopping. And then she drove farther away from her house. And she came to another stoplight. Finally, when the light turned green, she continued to drive away from her house. So something like that. Doesn't say what speed she's going. So all of these lines are not have to be the same. 25 miles per hour. But you definitely have to have these because you stop waiting to move farther away from her house. Okay? So you get a half a point for that, and then a half a point for another description. Did anybody come up with a good description for that? What did you say, Bridget? Okay, well, so I need to know the variables though, because that's really important. What are your variables when they run? What are the variables? What would be your variable here if it was running from your house? This is from the house, okay. Anybody have a different one? I said, what if this was money in a bank and this was time? So here you're making a weekly deposit, and then here you stop making deposits, so your bank balance stays the same. And then here you start making more deposits at a constant rate, and then your bank balance stays the same. And then here you start making some more deposits into your bank. Just make sure you include your variables. Okay? All right. You guys feel prepared pretty much? Okay. So you're going to need to practice this weekend because that's what you do for a math test, right? So remember, you can watch this video on, go to Google Classroom, and then the link will be there, take you to YouTube. And then right now we're going to practice until lunchtime, which you guys are going to have probably time to hopefully finish this. Okay.
What?
Yep.